Find the dy dx of this. We are still on differentiation chain rule shortcut method, but this is another form of functions. So now the one we did in our previous class under this shortcut, we are having the function algebraic function, or let me say we are having polynomial when you have something like x to the power of n. But in this case here, you can see whenever you have like sine function, you have logarithmic function. So what are you going to do? So instead of you using chain rule, so in a short way, then you get your answer correctly. So now a, so we have y to be sine s squared plus 1. So now we want to know the dy dx of this function. So it's very simple, right? So what we are going to do is that firstly, let's get the derivative of this inside the parentheses, that is d dx with respect to x of s squared plus 1, then multiplying by, so we are going to find the derivative of sine function. Do you understand now? Derivative of sine function. So now the derivative of sine function here, for example, this is what I'm saying. You know, when you have sine x, the sine x is going to give us cos x. But here we have sine s squared plus 1, right? So if you want to find in this case, if you want to find the derivative of this one, according to what we are doing here, so this is going to be cos, right? Cos s squared plus 1. I don't know. Are you getting what I'm saying at all? So therefore, you take this s squared plus 1 as if it is x, just a variable. So therefore, we're going to have this to be cos So we have this to be cos, then repeat this thing here, s squared plus 1. So now here is that when you are differentiating sine, you know it's going to give us cos. Then you repeat the same thing here, and that's all. So from here, we have dy dx. So dy dx is now going to be, let's differentiate this. Differentiating x squared, you're going to have 2x. Differentiating 1, that will be 0, right? So 2x plus 0, we have 2x. Then multiplying cos s squared plus 1, right? So therefore, we have our final answer to be 2x cos s squared plus 1. That's the solution for the first one. Can you see? So simple. Now let's look at this second one. We are going to do the same thing. Whenever you have ln here, so therefore the first thing we're going to have, we have y equals ln of cos what? Cos x. So now from here, the next thing we are going to do is that to get the dy dx. Are you following? Alright, so to get the dy dx of this, the first thing we are going to do, find the ds of this function inside the parentheses, cos x, then multiplying. This is what you are going to do here. You know, ordinarily, if you want to differentiate ln u, that is dx of ln u, so this is going to give us 1 over u, right? So ln that is here now is going to be 1 over, what is our u? The u is cos x. You repeat it, cos x. Are you getting what I'm doing? So now from there, you're now going to have, what is the derivative of cos x here? That is minus sine x dot, you can see this is 1 over cos x. So now from here, you see that when we multiply this by this, we're going to have minus sine x over cos x. Then recall from the trig identity, recall from where? From trig. when you have sine x over cos x, okay, this will give us tan what? Tan x. So therefore dy dx here is going to give us minus what? Minus tan x. That is the derivative of this function here. So is what? Is minus tan x. And that is the end of the class. If you find this class very interesting, kindly share this to your colleagues. Let them learn from it. Follow for more updates like this. Bye.